Hey y'all, it's me, Miss B, and today we're talking about unit vectors. We're talking just about unit vectors today. Okay, so there are, we have the unit vector, but we also have the zero vector. So the zero vector has a magnitude of 0, it's a point, and it has no direction. So if we were graphing it, it would just look like this. Doesn't have an arrow on it because it has no magnitude, because it's 0. And if it doesn't have an arrow, can't have direction. Okay, so then the dot product of any vector and the zero vector is the zero vector because of the fact that 0 times anything is 0. And then, so then we have our unit vector, which the unit vector has a magnitude of 1, which is like a unit. And then we have, basically the use for it is to provide direction in application problems. Okay, we have 2 unit vectors. We have I, which is 1, 0, and j, which is 0, 1. And that is what they are. So when we write out, like 5i minus j, that's because we're multiplying it by those units. Those unit vectors. And remember to just make your eyes curly so it doesn't look like a 1 when you're writing it quickly. Okay, so when we're finding a unit vector, we are going to use these 2 equations. So you can use either one. You don't use both of them. Some people get confused. Some people don't like to see it this way. They like to see it this way. It's really just dependent. So use pink or purple. Don't need to use both. They're the exact same equation. In the same way that you would say 2 over 2 is the same thing as 2 over 1 is times 1 over 2 is the same thing. Okay, so that's basically what that means. All right, so let's go ahead and find this unit vector. I'm gonna change my color back because I don't really like this one. All right, so let's find a unit vector with the same direction as v. So v is here. Let's go ahead and I'm gonna just use this equation here. So I need to find the magnitude of v, which using that equation that we had before. So we end up doing 3 minus 0 squared plus 8 minus 0 squared, because this is the initial point is 0, 0, and the terminating point is 3, 8. It is kind of redundant, but just showing that step. So then we have 3 squared, oh goodness, 3 squared is 9, plus 64 is the square root of 73. And we'll just leave it exact. So then we're going to do 8 divided by radical 73, which is equal to 3 over radical 73, 8 over radical 73. Oh, goodness. Don't like radicals in the denominator, so I'm gonna multiply each of these by radical 73 over radical 73, which is a form of 1. So we get 3 radical 73 over 73 and 8 radical 73 over 73. And that right there is my exact form of my unit vector. And then if we want to approximate to graph it, it's about 0.35, 0.94. Just be careful when you're typing that into your calculator. Okay, go ahead and try this next one on your own. All right, so let's first put it in component form. So this is equal to 5, negative 12. So then the magnitude of v is equal to square root of 5 squared plus negative 12 squared, which is 25 plus 144 square root, which is equal to the square root of 169 equals 13. Nice and clean number. So I'm going to take 1 over 13. Let me change color here, just to make it fun. So I'm going to do 1 over 13 times my original vector of 5, negative 12. So I get 5 over 13, negative 12 over 13 for that vector. All right, finally I have a direction angle. Mostly use these for application problems. Oh goodness. All right, and direction angle, here's the definition. The angle that a vector makes with the positive axis, which is usually the angle we're looking at, is the direction angle. So if I were to draw some random angle in here, then this is the angle we're looking for. That's the direction angle that it's creating with the positive x-axis there. Okay, so we can write a vector in terms of its magnitude and direction. So this is the formula for that. So that is magnitude of v cosine theta I plus magnitude of v sine theta j. And you can also write it in component form where this is your x and this is your y. I guess I can go ahead and write that out really fast. So this would be just like that. And remember, we know that cosine is x and sine is y, so that's pretty straightforward there. Okay, so let's go ahead and do this example problem. So the wind is blowing at 30 miles per hour. So, and then in the direction of north 25 degrees west, express its velocity as a vector in terms of I and j. So this right here, that's our magnitude, 30 miles per hour, how intense it is. And then the direction is north 25 degrees west. Now, if you remember before, I have to write out this every time because I'm that way. So then we have starting north, going 25 this way. So starting from the north, going 25 this way to the west gives us our angle. That's not quite on the 25, but you should get the idea. So there's my angle. We want to make it with this axis right here. So we're trying to find what this whole angle is. So we're going to do 90 plus the 25 equals 115 degrees for theta. So theta is equal to 115 degrees. All right, and then our magnitude given to us is 30. So then I'm just going to plug and chug into this equation, which is magnitude of v cosine theta I plus magnitude of v sine theta j. So we just plug in, so we have 30 cosine of 115 degrees I plus 30 sine of 115 degrees j. And we won't worry about making it exact. We'll just leave it as is. And so this ends up being, when we plug 30 cosine of 115 in our calculator, we get negative 12.7 I, and then plus 27.2 j. So go ahead and pause, make sure you get that. Also make sure your calculator is in degrees for this problem. Okay, so then go ahead, try this problem on your own, and we'll go over it together at a later time.